Welcome to this specialized training module on information systems implementation. We are moving beyond development and into the critical phase where systems are prepared for the real world. This session focuses on system readiness and implementation testing, ensuring that what we built actually works, is secure, and adds value. We will cover the rigorous testing hierarchies, migration strategies, and the formal processes of certification and accreditation required to go live. Let's begin. We start by defining our scope. Information systems implementation is the bridge between a theoretical design and a functional business tool. It involves much more than just installing software. It requires a holistic assessment of system readiness. This means verifying that the software code is bug-free, the hardware is stable, the data is accurate, and the users are trained. The core activities we will explore include various levels of testing, the delicate process of data migration, and the strategic decision of how to cut over to the new system. Our primary objective is to ensure that the system not only works technically, but supports the business goals defined in the early requirements phase. If we fail here, we risk operational disruption and financial loss. This flowchart illustrates the transition into implementation. We exit the development phase and hit a readiness gate A check to ensure we are ready to proceed. Once in the implementation phase, we execute 3 parallel tracks: testing the software, migrating the data, and training the users. All 3 must complete successfully to reach the go-live decision. Only then does the system move into production operations. This visualizes that implementation is a multifaceted process, not a single step. Before we can test the system as a whole, we must verify its parts. This uses a bottom-up approach. We begin with unit testing. This is often called white box testing because the tester, usually the developer, looks inside the box at the source code to verify logic paths and syntax. Once individual bricks are solid, we move to integration testing. Even if 2 modules work perfectly alone, they might crash when they try to talk to each other. Integration testing focuses on these interfaces, ensuring data flows correctly between modules. Catching bugs at this stage is significantly cheaper than finding them during user acceptance testing. This diagram shows the bottom-up testing hierarchy. We start at the base with unit tests for individual modules like Module A and Module B. These feed into the integration test layer, where we check their interaction. Only after these pass do we move up to the broader system test. This structure ensures that foundational errors are isolated and fixed before testing the complex whole. Once components are integrated, we perform system testing. This is often black box testing. We don't care about the code. We care about the output. If we input A, do we get B? We must perform specific types of system tests. Recovery testing ensures the system can bring itself back up after a crash. Security testing validates that our access controls and firewalls actually keep bad actors out. Stress and volume testing are critical. The system might work fine with 5 users, but will it crash with 5,000? We overload the system intentionally to find its breaking point before the real customers do. This mind map breaks down system testing into 3 critical branches. Functional testing checks if the system does what it's supposed to do using black box methods. Performance testing pushes limits through stress and volume tests. Resilience testing ensures the system stays alive through recovery and security tests. You must verify all 3 branches to declare a system ready. The final hurdles are QAT and UAT. Quality assurance testing, QAT, is typically done by IT. It focuses on technical standards. Does the system meet the spec? User acceptance testing, UAT, is different. It is performed by the actual business users in a secure environment. They ask, can I do my job with this? They test real-world scenarios. If the system calculates a mortgage perfectly, QAT pass, but requires 50 clicks to do so, UAT fail, the system fails. We also perform sociability testing to ensure the new system doesn't crash the old systems running on the same network. Formal sign-off on UAT is the green light for deployment. This sequence shows the handover. ITQA performs the technical QAT first. They release the system to the business user for UAT. The user tests scenarios. If they find a defect, it loops back to IT. If UAT passes, the user gives formal sign-off to management, who then approves the move to production. This emphasizes that IT cannot approve the system for the business must do it. A great system with bad data is useless. Data conversion and migration is a high-risk activity. We must move data from the legacy system to the new one without losing a single bit. This follows the ETL process: extract, transform, and load. The risk is that data fields might not map correctly. For example, moving a name field into a date field. To control this, we use strict validation. Record counts, did we move 1,000 records and land 1,000? And hash totals. We perform mock migrations dry runs to test the scripts. Finally, users must verify the data in the new system before the old system is turned off. Here is the migration flow. We extract from the legacy DB into a staging area, transformation engine. We cleanse and format the data. We load it into the new system DB. Crucially, we then hit the integrity check node. If the counts don't match, we go back to staging. If they pass, we reach data acceptance. This validation loop is essential for data integrity. How do we flip the switch? We have 4 main strategies. Abrupt changeover or cutover is risky. You turn off the old and turn on the new. If it fails, you are down. Parallel changeover is the safest. You run both systems at once. If the new one fails, the old one is still there. However, it's expensive because you do double the work. Phased involves moving one department at a time. Pilot involves testing in one branch office before a global rollout. Every strategy must have a rollback plan, a panic button, to return to the old system if things go wrong during deployment. This chart helps you choose a strategy. Abrupt cutover is in the bottom right. Low cost but high risk. Parallel operation is in the top left. Low risk but high cost. Phased/pilot sits in the middle, balancing risk and cost. As an auditor, you want to see the organization justify their choice based on their risk appetite and budget. Before flipping the switch, we need 2 formal steps: certification and accreditation. They are often confused. Certification is the technical test. It is a comprehensive evaluation, verifying that security controls and functionality work as intended. Accreditation is the management approval. It is the official authorization by a senior executive to operate the system, accepting any residual risks identified during certification. You cannot have accreditation without certification. As an auditor, you verify that management didn't just sign the paper, but actually reviewed the certification results to make an informed risk-based decision. This flow shows the approval chain. We start with testing results feeding into the certification process, the technical review. This produces a report for the accreditation authority, management. They have a choice: accept risk and authorize operation, or reject risk and send it back for remediation. This ensures no system goes live without executive ownership of the risk. The project isn't over when we go live. We must conduct a post-implementation review. This happens weeks or months later, once the system stabilizes. We ask the hard questions. Did we actually get the benefits we promised in the business case? Did we stay on budget? Are the users happy? We calculate the actual return on investment, ROI. This review captures lessons learned to prevent repeating mistakes in the next project. It is the final quality gate that closes the project lifecycle and transitions the system into ongoing maintenance. The final diagram shows the post-go-live cycle. From go-live, we wait for the stabilization period. Then we conduct the post-implementation review. This generates ROI analysis and lessons learned. Crucially, these outputs flow into future project planning, ensuring continuous improvement for the organization.